We're going to be talking about earthquakes, and specifically in the Asian region, because the unit that we've been learning about at the moment is natural disasters and Asia. So China and Japan have some of the most earthquakes in the world, with China's earthquakes accounting for over half of all earthquake deaths. So what are earthquakes? So earthquakes happen all the time. It's only when they're really big that we can feel them. The Earth has lots of major layers, okay? And these layers are like jigsaw pieces, moving and bumping into each other all the time due to pressure underneath. When this pressure builds up and causes the plates to move in a sudden jerk, that's what causes an earthquake. And this can cause damage to buildings, to roads, and if it's at sea, it can cause damage by making big waves as well. So this is the Ring of Fire. Now, New Zealand, our neighbour, is part of this Ring of Fire. This Ring of Fire has 90% of all earthquakes happen in it. There are 450 volcanoes in this Ring of Fire. So there's a lot of stuff going on here. The largest 3 volcanic eruptions to date actually happened here. So people actually do die, unfortunately, and they lose their homes to earthquakes. And this is a real shame. But earthquakes don't have to be massive to kill people as well. We measure earthquakes with on a magnitude, and there was an earthquake in Japan that measured 8.9, and it killed 28,000 people. But there was a much smaller earthquake that measured 7.0, and we'll discuss these numbers soon. And this was in Haiti, and it resulted in over 222,000 deaths, which is a lot more than the bigger earthquake. So can you think of the biggest earthquake? What's the biggest earthquake you can think of? And no, it wasn't the one in Grand Theft Auto 5. The biggest earthquake was in Chile in 1960. This is the one that we can measure, and it recorded at 9.5. Before we were able to measure them, though, the deadliest was back in China in 1556, and it killed 830,000 people, which was 60% of the population. Earthquakes can come in 2 types. There's mountain slope earthquakes like this one in the picture from Japan, and this can cause massive mudslides to take out towns. We also have seabed earthquakes. This one is also in Japan. This is from 2011. So what happens is an earthquake is in the water. It causes massive waves, which are then called a tsunami. And this tsunami can cause devastating loss of people. This one here was 15,000 people in Japan. We can use early warning systems to help because we don't know when an earthquake is going to happen. We don't have the technology to do that yet, but we are getting these early warning systems in place. Just like the CFA app that we use in Australia to let us know when a fire is coming towards our house, California has an app about earthquakes. How exciting is that? So this is how we understand them better. And this is a seismograph. And in a moment, we're going to break off into groups, and we're going to, challenge each other's ideas and build one of these seismographs ourselves. So this bottom, during an earthquake, the bottom of this seismograph, it moves with the earthquake, and the top section doesn't move. The measurement between those 2 sections, the movement and the non-movement, is what we record on this bit of paper. And this gives us the number we discussed back before, the 8.9 magnitude or the 7.1 Haiti magnitude that we were discussing. This lets us know how big this earthquake is. And it's this information that we can learn from reading current earthquakes. It's going to help scientists make early decisions to help us when earthquakes arrive. So what we're going to do today is we're going to make our own seismograph. And we're going to very carefully go off and break into groups of 2 or 3. We're going to get some materials to help build it. We've got some materials over there in the corner, and we're going to use these materials to help build our own seismograph. Now, we need to do this carefully. We need to be considerate of each other, and we need to discuss things before we just rush off and do it. So jump into your pairs now, grab your materials, and I'm going to come around and see how you're going with your own seismograph. Let's really challenge each other's ideas and see what we can come up with.